So Matthias Geiger is an electrical engineering student from Germany. He got involved in Debian development because he wanted to run apps that hadn't yet packaged as Debs. So he's contributed to a variety of app platforms, but today he's specifically talking about Rust apps. He was able to package, get the Rust GTK and lib and layer bindings updated to get the latest known serverless apps into Debian. So I'll let him lead from there.
Thanks for the introduction, Jeremy. So a bit of an introduction because, like most people probably don't know me, I'm Matthias Geiger. I started using Debian around 2017, and yeah, I kind of was, intrigued by it that you have a system you can configure however you like and have that freedom. And like probably some people in this room, I started using it and it was fine. I liked it. And then I was wondering, hey, this is a nice application. Why isn't it, available yet? And that's where I kind of got sucked into packaging. And that's where the whole process started for me. And ironically, the app that inspired me to do packaging, it's still not in Debian, but a lot of progress has been made towards that, and that's what I'm going to talk about today. Yeah, apart from Debian, I do things like hiking, or I like to read. Yeah. So I'm going to do a real quick introduction to Rust. So it's programming language, sorry. And the interesting thing is that it's memory safe by default. You might know from C, you can directly make calls to memory with things like malloc. Rust by default forbids that, so it's memory safe and it's automatically garbage collected. There are ways around that, but the default is you can write a memory safe application. Rust C is the compiler. It's also the Debian or Ubuntu packaging for that. Then we have Cargo. That's both the build system and kind of the package manager. It's a bit similar to pip, if you know it from Python. Can you hold the mic? And it uses things called crates to build the actual binary. Yeah, crates are kind of like the equivalent of C or C++ libraries. There exists a variety of them. It's kind of extending the standard library to do things you can't do with the standard library. For instance, if you want to do something with, say, OpenSSL, there's an OpenSSL crate you can use. And then you have the documentation and all the interfaces and classes you need to use. And then you use that OpenSSL crate. They are all distributed by upstreams at a central registry called crates.io and by a multitude of contributors. So it's like everyone in theory can write a crate and put it out there for people to use. Yeah. Then we have Dev Cargo. It's kind of like a Debian internal thing, but I'll still mention it because it does a lot of heavy lifting in the back for us in the end. What it essentially does, it pulls the source from crates.io and then automatically resolves all dependencies, creates a Debianized source directory, prints out the rules file and generates a test file. It's basically, does all the heavy lifting in the background So for us as packagers, it's really easy to actually package a library or an application, so we don't have to do all that by hand, because that would be a lot of work. Yeah. So here's an overview of projects written in Rust. You might know some of the names. I'm going to do a quick explanation here that you can get an overview of what actually is already written in Rust. So we have here binaries. That's like CLI programs, for instance, bat, exa, ripgrep, and core utils rs. Those are mostly improvements or better newly written command line tools to help you work more efficiently with desktop, like bat, for instance. If you bat a file, it's the same like cat, but you have a call it output, which is really nice. Then you have user programs like obfuscate, for instance, or loop. That's a new image viewer by GNOME. And there's also libraries written in Rust. And there's also kind of like two types. It's dynamic libraries like librsvg2. And like if you're using GNOME, you're already using that library. It's written in Rust and it compiles into a SO file, so a shared object file, and it does all the SVG rendering in the background. And then there's also, for instance, Python cryptography. That's a really common library, and that's also completely written in Rust and compiles to Python. So if you're programming with Python, you might have already used that one. Now I'm gonna explain a bit about the packaging workflow. Kind of like the most important thing is that we maintain rustc, cargo, deb cargo as mentioned previously, and rustup. Rustup, for those who don't know, it's basically lets you install the Rust toolchain separately. That's especially useful for developing if you want to have the latest nightly features. We have one big repo where all the crates live, and also the binary crates I mentioned previously. So essentially what we do is we maintain those. So we update them to the latest version, see if patches can be dropped, if we can simplify the packaging. And we also do like updates, big transitions, and bug fixes, and remove old or obsolete packages. Then if you have a Rust project you might want to package, there's usually a huge dependency tree. And a really nice tool to take a look at that is running cargo deb status. That's also written in Rust. And here we have cargo deb status running against this magic wormhole implementation written in Rust. And you can see it nicely prints all the dependencies and highlights the ones already present in green. So you know which ones you don't have to tackle. And the ones currently pending review are here in blue. And the ones not in Debian yet are white, as can be seen here. So that's a really nice way to get all the dependencies and kind of get an overview of how much work it would be to get this application, whether it's a library, a CLI program, or a GUI application into Debian. Packaging the actual crate itself, like for instance, here, if I would probably start here, because I can see this dependency is already pending review and all the others are in Debian. So I would start working on that one. And we have two simple scripts for that also do a lot of heavy lifting in the background. And basically, in the best case, what we have to do is edit the copyright. So that kind of holds all the information, who wrote the source code, what's it licensed under, is it GPL licensed, is it MIT licensed, and so yeah, people who want to use that know how they can use the source code. And then we have a TOML file called debcargo.toml, and that also holds meta information. Like, for instance, if you need to specify a dependency for this crate, you can just put it in there, and Debcargo does all the heavy lifting for you in the background, which is really nice. Sometimes we have to patch the source code, so we also put patches in there. And sometimes we have to kind of, tweak the test so at least some of them can run. Like, an example would be a test that requires network access. Like, as you can imagine, that's not really possible with a self-contained build system. So we need to disable that too, if the crate uses that. Here you can see actually a Rust library. That's async TLS in that case. And I've printed here terminal output to show all the kind of information here. And what kind of is interesting, you can see all those virtual packages it provides. That's called features in Rust. So some crates have features. That's essentially flags in the code you can set or use to enable specific behavior. So for instance, that one, web PKI, it's used for certificates. So if you use that library with that feature, it provides that for you. But the source code is the same. It's just virtual switches or virtual packages in that case that are provided here. And you can also see the dependencies here that also makes use of those virtual packages. And you can also see the versions, the versions it needs as dependencies. And that is all automatically generated by Debcargo. And as you can see, that really saves us a lot of work. So we don't have to type all that by hand. And I'll talk a bit more about features later. Now we get to the interesting part, GTK-rs. It's kind of, well, it's not new anymore, but GNOME has started to generate Rust bindings for its C GTK libraries. So they're all building on top of glib. Then you have, for instance, you have a crate called glib, you have a crate ATK, and so on and so forth. In total, it's 50 crates about, and that's both GTK4 bindings, GTK3 bindings, and the base core bindings like glib, for instance. And usually you have one low-level sys library that directly interacts with the C code and also directly calls into that. And then you have a high-level library, kind of like a safe wrapper around that. So you can make safe and, in this context, memory safe API calls. And an example would be libadwaita sys and libadwaita. So there's usually one sys crate and one high-level crate. And most applications nowadays are already have switched to GTK4 and usually libadwaita, because that's the current tech stack GNOME uses. And yeah, GTK3 RS is slowly being deprecated. So kind of like that's the future here. Yeah. Then we get to how does it actually work if you have all dependencies packaged for an application and want to actually build it. First of all, you have to kind of translate the dependencies of this package in cargo.toml into Debian ones. The nice thing here is that only the two files, Debian control and Debian rules, are kind of Rust specific, and the rest is the regular Debian or even Ubuntu workflow. So you can reuse all the tooling that's already in place and don't have to do a lot of things differently. The current issue still is that, similar to Go, Rust is statically linked. That means all dependencies get linked into one final binary, and you kind of have to use the specific version in this point of time. But yeah, this is dynamic linking in Rust is still being worked on, so that won't happen anytime soon. Yeah, here we can see a cargo.toml for GUI package written in GTK and Rust. So here you see the key dependencies, and then there's all these dependencies listed, and that is the crate names. And as you can see, here's the features again I was talking about. So for instance, here GTK4, it's specified it's at version 0.7, and it needs the GNOME 45 feature. And similarly here at Wada, that's libadwaita at version 0.5 and needs the version 1.4 feature, which just means it expects that to be present so it can link against that specific API. Yeah. Now we'll take a look at what that looks like in a Debian control file, which also has those dependencies, but in a Debian way. And it looks like that. I hope the people in the back can still read it. But essentially, here you can see the same dependencies with their features. So here it's, for instance, librust libadwaita 0.5 plus version 1-4. So that's the same feature, but translated into Debian packaging. And yeah, the rest is pretty much standard workflow. So you specify all the Rust dependencies you need in here as dependencies on a build depends, and then you can go ahead and build a package. Simple as that, right? The only other difference is that we want to build offline, because usually cargo build, if you call that, it pulls from crates.io, which is the online repository I mentioned, and that does an online build. So we usually don't want that. So it looks complicated, but it's just a make file that sets a few flags, and here uses this specific local registry and tells cargo, please use the local registry with all the Debian packages and the source code and link that and build from there. So it's totally offline. Why do we do all that? It's a lot of work. There can be huge dependency trees to go through. It doesn't matter whether it's CLI applications or GUI applications. So sometimes you end up tackling one dependency and then it's like 20 others, normal day. But what are the advantages So a wide range of architectures are supported actually. You have AMD64, all the ARM versions, i338, so 32-bit. You have MIPS and RISC. That's actually a recent addition, and S390X. So if you ever want to run a Rust application on your mainframe, now you can do it. The binary package do not really depend on any runtime, which is the case for Flatpak. So it's really just one final binary, and yeah, that results in an architecture and size optimized package. And it also helps the wider Linux ecosystem. So Linux Mobile is slowly gaining traction, and once a package is built, for instance, for ARM, they can just use that and install it from the official repos and run it on their phone, which is pretty cool. It's also reproducible build. That's important security-wise because the build runs offline and solely with Debian tooling and Debian packages, so it can be redone anytime. And then we have a small, view about what's currently in Debian. Over here. Well, so we have Album, Obfuscate, GNOME Tour, and Metronome. Those are like 4 apps, and work is still ongoing for those. That's WAR, the new image viewer by GNOME, which is becoming default in GNOME 45, and Snapshot, which is also becoming the default camera app in GNOME 45, and Shortwave, which is for you can listen to internet radio with that app. Yeah. And to summarize it up, we did a short excursus on the Rust ecosystem. We learned a bit about the Debian Rust tooling and a bit about Debian specific tweaks and GTK-rs stack and how applications get packaged for Debian. Yeah, that would conclude my talk, and I think we still have time for questions.
Anyone have any questions? Watch your head.
What do you do if you've got 2 applications which depend on incompatible versions of a dependency? Do you handle that with your Debian package?
You mean if there's two there's 2 applications depending on separate versions of the same package, right?
Incompatible versions, yeah.
Yeah, usually if it's just a minor difference, we try to patch it. That's actually pretty common because, either our workflow is faster or different upstreams are slower, or, it's the other way around. So usually we patch it. Like, for instance, patch from 0.4 to 0.5 is usually fine. Of course, you have to check, if the API changed, if there are any breaking changes, etc. And if we can't patch it, we introduce SEMVers, that's short for semantic versions. So you have a package providing, for instance, the 0.4 version, and then the new package gets updated to 0.5. So the old package is still depending on 0.4, can still use that, while 0.5 is also provided. Yeah.
I'm wondering, I know that the Debian, Rust compilers typically tracks behind what's current. So if I'm working on a Rust program that's using the latest Rust C compiler, and then I want to package it for Debian, it uses an earlier version of the Rust C compiler, are there any tips or tricks of being able to transitively go through all the dependencies and go back to a version of a given dependency that is built for that specific version of Rust-C?
Yeah, you'd have to, I think, try case by case. For instance, with the latest GTK-rs update, they bumped the minimum supported Rust version to 1.70, I think. And what I did, because the version was lagging behind in Debian, I just patched it, and it kind of worked for half of it. And then I had to wait until it was updated. But you can usually, try patching the MSRV in cargo.tml and see if that works. And if not, yeah.
But there's no trick to, like in the cargo metadata, you can tell which version of Rust-C is compatible with a given cargo package. There's no trick to just fixing up your cargo.toml based on a given version of Rust-C compiler. You have to do it by hand.
Yeah, I know what you mean. I don't really know, to be honest. Like I said, you can always try patching and see if it compiles against this older version. And if you need a newer Rust-C for developing, you can always install RustUp, which recently was added into Debian and by extension Ubuntu. Yeah.
Thank you.
Yeah. And what steps did you take to ensure that if you just change some dependency version of the Rust package, that you don't introduce, that still compiles, but you introduce behavioral changes that lead to subtle bugs?
Yeah, usually we check the upstream release notes to see if there were any breaking changes in, API, etc., like I mentioned. And we also run the test suite for, like, if a crate has a test suite, we usually run it. So all the tests get still run and executed. And yeah, we just hope no bugs get introduced, but usually upstreams are quicker than us to accept new versions. So if, a new version would break something, usually you can check if there's an issue been reported and then go on that.
With that, we